someone has shared that the Ugandan site has been hacked. So what happens after? What happens before? How can we protect ourselves? How can we protect ourselves? You know, and a few things that we can do that we are going to learn today. All right. So I'm going to switch between these notes and mine because these ones are a bit heavy on the Queen's language. Right, so today we're going to learn about how to protect our data, the things that we can do to prevent our data from getting lost, from being tampered with, from being inaccessible. And a tip, we are actually going to learn about cryptography, encryption, hashing, giving permissions to people who can access our data, as we also proceed on security. Security is a bit long, but let's go ahead and learn. All right, so you remember, guys, on Wednesday, we learned about, was it Wednesday? Yesterday or yesterday? Yesterday, yes. We learned about the different life cycles we have on security, and the first one is prevention, where you prevent your resources and your data from being attacked. Then there's detection. So if there's anything that has happened to our data, if maybe there's any weakness, how can we detect it early? And then the third one is responding to it. How soon and how fast, and what can we do to respond to an an a threat event or an attack. And finally, we have analysis. How can we learn from whatever happened? What can we do better to improve our availability of data and resources, plus confidentiality and integrity? And on that, we also looked at the CIA triad, where we looked at confidentiality, and we learned what confidentiality is, ensuring that data and resources are only accessible to those who are authorized to access. Then we have integrity, ensuring that data is not tampered with and that it is correct. And then we have availability, when that data or that resource is needed, it is there, right, by those who are authorized. And when it comes to protection of data, remember, guys, yesterday we touched on protecting our data both at rest and in motion, right? And we said at rest is when it is when data is in storage. When data is in motion, it is when it is being transmitted from one host to another. All right. So here we can see how some of the things that we can do to protect our data. For example, in this example, we see that when data is being transported, when data is being transmitted, it's being reversed. It's like it's being encrypted, right? Even when data is at rest, it's being encrypted, and you cannot know, unless maybe you have the keys or the codes, you cannot know maybe the type. Let's start with cryptography and encryption. Let's see how we can protect our data using cryptography and encryption. And this is where they are a bit easier to assimilate. All right, guys, let me know if you can see my screen clearly. Let me know, guys, if you can see my screen. Awesome. Awesome. Thank you. Thank you, Tony, and everyone. Thank you, Gideon. All right. So, guys, there's something called cryptography. Those who are, I'm not sure about other unis, but I remember back in my day when we were in uni, there was a whole unit on cryptography and encryption. And this is one of the units that very few people attended, and one of the units where most people got D's. Why? Because you needed to learn how to use cryptography to encrypt your data, decrypt, learning the different methods of encryption that there are. For example, like the RSA, those who are went through the software engineering of ALX, the 13-month program. I'm sure you guys, you remember doing a whole bit of cryptography using the RSA and hacking, rather, those fancy things that we did in ALX, trying to hack someone or hack. I remember one of the projects was to hack one of the, like, this lotto projects that we have, right? So today let's look at cryptography. And cryptography is the study and practice of securing data and information. And this ensures that our data is confidential, meaning that it is only accessible to those who are authorized to access it. And it ensures integrity, ensuring that no one tampers or changes anything in our data. It uses mathematical techniques. Remember that we were using algorithms. Haya, tutatumwagia mchama hapa na tutafurahi. Tutasikiza moshene yenye ipendi uzembe. Then actually, one of the things that are included in cryptography is encryption. And for our class today, we're going to learn a little bit about encryption and know why it's important, the different types of encryption there are, when to use different types of encryption, right? So, what is encryption? Encryption is you take a piece of data or information and you convert that data into unreadable text that can be transported or even stored and can only be accessible to someone who can decipher your data, the code, okay? So encryption is turning your readable text. For example, if I encrypted this word encryption, I encrypted it, say, using the code, maybe after, maybe I encrypt using maybe a code of 4. I don't know if you guys can remember. Uh, this would mean that each letter, so for you to get letter E, you have to go 4 letters after E. So maybe the E would be F, G, H, I. So maybe the E will be an I, N, O, P, Q, R. N will be R, R will be S, T, U, V, something of the sort. So at the end of this word, no one can even think. You will think that this is gibberish, but at the end of the day, if you have a code, you'll come and decrypt this and see that it is the word encryption. So encrypting data means that you turn readable data into unreadable data using an algorithm or a cipher. If you can decipher, then you can be able to actually understand and read the data, right? Then we go to a key. So a key is a string of numbers or letters that we use in the encryption or decryption of code. For example, now, like the one I have given you for encryption, let me just see if it is let me copy this word encryption and let you know what it will be if it has a key of 4. Right, let my good friend tell us. So it will be, somebody tell me if I use encryption. Let me see here. If I use the word encryption with a Caesar cipher of 4, what will this be? This will be an I. This will be an R, a G, a V, a C, a T, an X, an M, an S, and R, right? So if I was using a key of 4, well, a key is it's called this type of encryption is called a Caesar cipher, and it says for every readable word letter, actually it's a letter, for every readable letter, for you to decide, for you to encrypt it, move ahead on the alphabets from A to Z, move ahead 4 letters, and on the fourth one, that will stand for your letter. For example, if it's an E, we'd go to FGH and it will go to R, an I. If it is N, it will move 4 letters, it will go to R. So if I sent you this and I tell you here, you decipher this word, and the key equals to 4. You guys ask your Google or GPT to tell you, and then you let me know. So it should give you the word encryption. So encryption is you turn a readable word, like this word encryption, and turn it to something unreadable, like now this. So if someone sees this, they won't even know what you're saying. Okay. So a key is the string or of numbers or letters by algorithm that you'd use to encrypt. For example, my key right here is 4. So if because I've given you my key, that's when you can be able to decrypt this word right here. Okay. Have you guys understood that? Have you guys understood the basic meaning of encryption? Or all right, Abby. Yes, yes. Thank you, Daniel. All right. Thank you, Gideon. So why is encryption important? Number one, encryption will ensure that only those who have the key can be able to open and understand and read your data. All right. If you do not have a key, you cannot understand. For example, let me ask you about this word. Uh, we're going to get there, Gideon. Trust me. We are coming to there. We're coming to hashing. All right, guys. Try decrypt this for me. You see, I've given you this these two words here, but I did not give you a key. So who can take a wild guess and tell me what is the word? Just a wild guess. Imagine that we were communicating and I send you this. Who can take a wild guess? Anyone? Well, try this then with a key of 3 and let me know. Let me know what it says. Take a hoot. I think next Kahoot sijui tufanye hii alafu tuwapee 10 seconds. Tuone kama huyo mtu anakuanga wa AWS atashinda tena. Yes, yes, Mohammed. It's hello there. Yes, Leonard. Yes, Daniel. Yes. All right. So, yes, I'm going to tell you a story, very short story. So there was this couple, and this couple was, in a forbidden relationship, and they were not supposed to date. Back then, in the very olden days, back then when there was the Roman rule and all, and they were not supposed to date. So, apana, it's a Roman. We're just saying it's a Roman story. So, the couple was not supposed to date. So, what will they do? And they wanted to write each other letters and stuff. So one day, this guy, he's in his middle 20s. The girl is in her early 20s, and this guy sends a letter to the lady, and no one can see what is written. So it's just a blank paper, but on the envelope it has the address of the lady, and it was delivered to the address. When it got to the lady, no one could read, no one could understand. So the family thought, hizi ni story tu za ajabu, hakuna kitu, it's just a blank mail. But actually, what had happened is the guy had used, there's a type of writing where you can use like, I don't know if it's water on a paper, and when you invisible ink, yes. So he used the invisible ink, and the lady knew this, so she put water and she could be able to read. But then the writings were gibberish, just like what I've sent you guys. And if she knew that even if the guards came and they saw, they will not be able to understand, but she had the key, so she deciphered the message and replied to the email, the mail, and that's how this couple were talking and how they continued with their relationship up until they planned on how the lady is to escape, the guy is to come pick her, and I hope they had a happy ever after. We unfortunately don't know the ending, but yes. Eh, so it's quite important. So now we know. Really, Daniel, look at you. Hujawahi penda mtu. We have seen people who have never loved. What's up? Kitu ya juzi, Patrick. Kitu ya juzi. Yeah. So imagine. So at least now we know at least one of the importances of. And you guys, were you writing letters when you were in high school? Because some of these things they were not you guys, you were doing. Tulikuwa na nini? Tulikuwa na nini just in siku zetu? All right. So people used to have secret codes for centuries, and even governments use these. Up to date, they actually do a lot of cryptography. For example, I don't know if you guys have heard that in the US they have a red phone, and this red phone is the only way that they use to communicate with, I think it's Russia. It's in the White House, and they just call it the red phone, right? But people think when you hear the word red phone, you think that it is a red, uh, wired phone, the one that had the numbers like, did you guys find those type of phones where they had like from 0 to 9 and you'd rotate one number to the next? So people thought that it is those type of phones, but actually they used to, instead of having a red phone that people would think it's a red phone that can be stolen, it was actually fax, and now they use email. It's not even fax. It's not even a phone by itself. All right. So let's continue ahead. Data encryption. So we can encrypt data, as we said, in two ways. You can encrypt data at rest, and you can encrypt data on transit. All right. Rather on motion, whichever you prefer. Um, So data at rest, you encrypt your data when it is stored either on a physical device or even on S3, on a database, on a backup media. And if you're storing your data in files or folders, you can use something called NTFS. Like Windows has NTFS, and it encrypts files. Using their encryption file system. Uh, Soon, when you start learning about services, you're going to learn also about AWS, EFS. You remember, guys, we told you that EFS is just Linux, but we also AWS supports Windows in some way. So you're going to learn about this NTFS and even something called Windows FSX for Lustre, right? So one of the ways that you can encrypt your data, if it's in a file system, you can use specific files like Windows NTFS, which comes with encryption. When you're storing data in a drive, you can you can you can encrypt an entire drive or even the data just stored in it. For example, you can use BitLocker. I know some of you have done this. Some of you have used this. It was quite common a few decades ago when we had to use drives a lot. And you can also use a VeraCrypt, which is an open source that you can use to encrypt the entire drive or a portion. And when it comes to data in motion, you can use SSL TLS. I think you guys have seen this, especially, for example, if you look at the URL that you're using right now for Zoom, it has a HTTPS, and HTTPS tells you that this particular website, or rather this particular domain, has SSL TLS certification. It has a security certification with it. And if a website has a security certification with it, it comes with a S after the HTTP. So SSL is secure sockets layer, and TLS is the transport layer security. And these are protocols used to secure communication between a client and a server. Then we have Kerberos, which is an authentication and encryption technology for networking environments. I don't know who mentioned it here. I think it was yesterday. Then we have IPsec, or IP security, which is a network layer protocol that secures IP communications by authenticating and encrypting each IP packet. It can work with both IPv4 and IPv6. It is commonly used in VPNs. And then finally, we have instant messaging or secure email. So secure email, mostly if you're going to set up, I don't know if you guys have set up email when you're if you, for example, you have your own domain, say for example, let me see, www.danielmusembi.com, and with your domain comes with you can create your own emails ending with .danielmusembi.com. say like info@danielmusembi.com or help@danielmusembi.com, if you want to receive these emails to your Gmail, there is a way that you can interconnect them. And when interconnecting them, you select the protocol, or rather the way that you want your data to be sent, right? Yes, Mozambique is actually called Moscow. Yes, Moscow. So, so if you want to receive your email, say from info@danielmusembi.com, you want to receive them in your Gmail at gmail.com. When you go to add incoming, rather how to receive other emails, you'll see on that window that Gmail gives you, you're going to see that it actually receives communication through TLS. When you're choosing the POP or iMac, the one that you how you want to connect your emails. All right. So here's a simple summary table of how you can encrypt data in various places. I'm going to let someone read this for us. Anyone who can read this for us, just unmute and read. Musembi, I've used your name. Kindly unmute and read. Anyone unmute and read for me? All right. Anyone, please.
Encryption type, purpose, examples of protocols. File system encryption protects specific files or folders. We have an example NTFS or EFS. Then for drive encryption, protect entire drives and their contents. Example, we have BitLocker and VeraCrypt. Then for web encryption, we have secure websites and online transactions. An example, we have SSL or TLS, HTTPS. Then for network authentication, we have it secures communications between systems. An example, we have Kerberos. Then for network level encryption, it secures IP traffic and VPN connections. An example, we have IPsec. Then for communication encryption, it secures email and instant messages. An example, we have TLS and end-to-end encryption. Yeah, thank you.
Thank you, Kevin. Thank you. You've gotten an engagement point. Thank you for reading for me. All right, so let's go to encryption. Let's see what encryption is and types of encryptions that we have. Number one, encryption is, we said we are converting readable data into unreadable data using a cipher or a secret key. And yes, so in encryption, we ensure confidentiality, number one, by using algorithms, so a mathematical formula and a key. Remember, we said that you can take a key, for example, a key of 3, and move it and move the alphabets to the next 3 letters after a letter. And we saw an example. For example, this is an encrypted message. And this is how it will look like. So imagine seeing something like this, you wouldn't even waste a second on it. But in real sense, it carries an entire message. And the goal of encryption is to ensure that your data is confidential. It is only accessible to only authorized people, nothing more and nothing less. Next, let's go to the types of encryption that we have. We have 3 types. We have symmetric, asymmetric, and hybrid. And for symmetric, it uses one key for both encryption and decryption. All right. For example, you guys, I gave you an example for the Caesar cipher where we used one key to encrypt and use the same key to decrypt. So that's a symmetric encryption. And advantages is that it is fast and efficient. It is fast for you to convert your data to unreadable and readable, and it is also efficient. It is easy. The disadvantage is that the key must be shared securely. So for me to ensure that a message I want to send you guys on this chat, for me to be able to give you my key, I need to ensure that number one, no one else out of this meeting can access the key. It's only you, the people in this meeting, can only access it. So there comes an issue on security of the key. On the second type, we have asymmetric, where we use different keys. One for we have a public key and a private key. In the public key, it is used to encrypt your data, and your private key can decrypt it. For example, we have RSA, and you guys remember when you're launching your instances, and you're going there to create a new key pair, huh? And you might not have actually understood, but you are creating a public key and a private key. And you are downloading one key, and the one key stays in the cloud. So that when you come here to SSH, when you're SSHing, your public key and your private key are in match, so you'll be able to access your server. But remember the very first time when you are trying to use their labsuser.pem or labsuser.ppk, labsuser.ppk, and unfortunately it was not the same key that we used for our server. We could not access our server because the public key and the private key were not matching. All right. And this is one of the most secure ways of encrypting your own data. Yes, Gideon, I hope now you understand. Yeah. And the disadvantage of this is that it is slower, because if you guys can remember, we had to, when we downloaded the key, we had to convert it to to be readable only, so that it cannot be changed, right? And before you actually create a connection when you are SSHing, remember that it took a while and it asked you, yes, yeah, that's ensuring that it's only readable. Now remember that when you are trying to SSH, it will take some time and then ask you, you want to register a new key in your system. Are you sure? And then you say, yes, you want to set up a new fingerprint. And then it says kidogo, and then it gives you the bad, right? So all that time it took, compared to I gave you guys a word and a key, and instantly you give me the response. So that's the difference between symmetric and asymmetric encryption. Then next we have hybrid, which combines both symmetric and asymmetric. And this is majorly used for SSL and TLS, for data in transit. All right. I hope you guys have understood. So some of the common uses of symmetric, where you have one key for both encryption and decryption, is like in payment systems, in database encryption, and in messaging applications. For example, your WhatsApp tells you your data is encrypted. End-to-end encryption, it's actually using the symmetric, because it is faster to decrypt your data, right? And the next one, uses of which this is not really important, but these are types of, yes, these are types of uh, these are some of the security standards that we have in symmetric encryption. I'm just going to pass through this because you see lazima mjue in details, unless you're doing cryptography and encryption. So one of the standards that we have in symmetric, I'm sure you have seen this a lot, is the AES, Advanced Encryption Standard, right? And it uses block ciphers, and it supports both 256, 198, 192, and 128 key sizes. It's the most commonly used of these other standards. For example, we have Amazon EFS. Amazon EFS, you'll see that it uses AES 256. You might actually realize that some of your drives as well, even in your, if you check some of the properties on your hard drives, for the files, they actually use AES 256. This, I don't know why, but it is most commonly used in files. And then we have the IDEA. Uh, it was developed and patented by Switzerland, free for non-commercial use, and it uses 128-bit key. Then we have the Twofish. Twofish is for public domain. It is open source, by the way, but it is a bit slower than the advanced encryption. Then we have TLS-SSL. This one we have said that it is for protecting data when it is being transferred. When we go to asymmetric, we say that it has two different key pairs. It has two different keys, one for encrypting and the other one for decrypting your data. And we say that it is much slower than the symmetric. Now, what are the most common uses of asymmetric? Number one, in encrypting your emails, in creating digital signatures, and in establishing secure connections. For example, like the example I gave you of SSH. Some of the standards that we have, it's RSA. So remember the type of example I gave you about ALX when we were creating our own. We're trying to decrypt an RSA key. Those funny projects of ALS. So RSA, it was developed by this person, and it uses prime number factorization, and it is one of the hardest encryption types that you can think about breaking into. And the other one is the DH. It uses a key exchange method. It's a key exchange method. It's not an encryption algorithm. The two parties share cryptographic keys over public network. Uses exponential and modular arithmetic. So while RSA uses prime number, the DH uses exponentials and modular arithmetics, things that in math we do not want to remember. Then we have this AI Gamal. It uses an encryption algorithm based on the DH key exchange principle. It provides strong security, but it is slower than RSA. So we understand that RSA, it could be faster and more stronger. That's why it is commonly used, the most commonly used asymmetric type of encryption. When we go to hybrid, we said that both hybrid uses both symmetric and asymmetric to encrypt its data, and it offers protection. It offers enhanced protection against key interception and unauthorized access, commonly used in secure communication protocols. So you can imagine if different governments are communicating, they want something that no one can intercept, no one can even know that it is going on. Okay. So some of the common uses, it's in the TLS, SSL, protection of data as it is moving, and in messaging applications, for example, in our WhatsApp and Signal and other type of messaging applications. All right, so we do not have standards, but it uses both. Now, in AWS, are there services that we can use to encrypt our data? And the answer is yes. So we have two major services, and one of them is called Cloud HSM, and the other one is called KMS, Key Management Service. Now, if you are going to advance from Cloud Practitioner, you go to Solutions Architect and you do Security Specialty. These are some of the things, and I think a bit of developer or even cloud ops, especially cloud ops for professional. These are some of the two common services that you'll be using in your day-to-day life. Reason is you need to protect your data even in the cloud, okay? And anytime that you see KMS, remember this even in your exam. Anytime that you see KMS, remember encryption. KMS is the only service that encrypts your data in the AWS. Now, for HSM is a hardware security module. Now, for HSM, it uses a physical hardware. So let's see the difference between these two. Okay. So AWS provide services to help you generate, store, and manage encryption keys. Right? We have the HSM, which I told you it's a hardware security model, and we have KMS. For HSM, a hardware security module is a tamper-resistant hardware device that you use to generate, protect, and manage cryptographic keys securely. Guys, I don't know if your laptops, some of these HP laptops come with a device that you can use to lock your laptops. And another one that the device you can actually use is for encryption. So in case like, for example, for those who use Paystack, if you do not want to just rely on password and 2FA, you can use a hardware module. So HSM is one of these hardware modules that you can use in AWS. And it ensures that no one can it generates your keys, protects your keys, and manages your cryptographic keys. Yeah. So in AWS Cloud HSM, it is a cloud-based dedicated hardware security module service, and it allows you to generate, store, and use your own cryptographic keys, and it is fully managed within a fully managed single tenant HSM module. So this means that one key is for one person. It cannot be used by multiple people because it's for protecting your keys. And the key features is that number one, customer managed keys. So when you come to learn about the services, you're going to learn about customer managed and AWS managed keys. For example, like S3 can manage its own keys. But now for HSM, you manage your own keys. You create your own keys and you manage them. For example, the way you have your key pairs in your downloads. You know, AWS does not care whether it is your downloads or you transferred it to a secure file with a secure folder with a password. No, customer managed means that you're in charge of your own device and of your own keys. So if you generate keys, for example, the way you guys generated your labsuser.pm keys, you are the one managing them right now. You decided when to delete them, when to change them, when to generate new keys. That's what we mean by customer managed. Then AWS gives us compliance support. So it gives basic requirements of customers who must use HSM. For example, government institutions, hospitals, banks, such. And then we have fully managed by AWS. Key export capability. You can export your keys to other on-prem or third-party HSMs if you need, and it has a dedicated hardware. Remember, guys, I told you that HSM is for hardware. Do not confuse this with KMS. All right, HSM is a real hardware that you use. Okay. And what are the common use cases that you might need a HSM? Um, you might need it if your applications require direct control over cryptographic keys. For example, those who use Paystack, I'm sure you have seen something like this. And if your workloads have strict compliance obligations, so for example, say if you're dealing with a lot of customer data, for example, if you're a government, if you're a bank, if you're a hospital, and integrations with custom applications. So if I had a HSM and I wanted to create a secure Paystack account, I'd use my HSM for there. All right, let's go to KMS. Now, KMS, this is one of the services that you're going to come into contact with a lot of the times, especially if you'll advance your career in the cloud. And KMS gives you KMS is a fully managed encryption key management service. It enables you to create your own keys, manage them, and gives you control over your cryptographic keys. Some of its features is that it is integrated with other AWS services. So, for example, you have your database and you want to encrypt your data, you can use KMS to encrypt your data, right? For example, like in this case, it can be integrated with S3 and EBS. EBS, remember, we said that this is a storage for EC2 instances. You can use it on RDS. RDS is Relational Database Service. You can use it with Lambda. Lambda is a serverless computing service. You're going to interact with it, Kidogo, and other services, even I think in ECS. And another thing that you can do, you can have automatic key rotation. So good conduct when you're using encryption is to rotate your keys once in a while, to ensure security of your keys. And the other thing, you can use access control. So it uses IAM policies to control the key usage. And this means that someone who does not have your key, and for example, if you've created 3 users, I've created user Kevin, user Daniel, and user Fan. If I give user Fan the key to my RDS, user Kevin to my S3, user Daniel to my EBS, user Daniel cannot access my S3. Okay. So you can use it ensures that you have access control even when you have different users. And it stores multiple keys. It can store your KMS default keys, the ones that are managed by AWS, and you can also store your own keys. So for example, if you have your own keys that you created, pole sana. So let's say that you have your own keys or even you have Cloud HSM, it can help you store those keys there. Auditability, CloudTrail. We are going to teach you about CloudTrail next week on Monday. You're going to understand that CloudTrail is for tracking who's doing what's going on in your cloud, in your resources. So with KMS, it can be tracked using CloudTrail and get to know who used a particular key where. Uh-huh. Integration between HSM and KMS. So the keys stored within HSM are for meeting compliance requirements, and you cannot. HSM is for, it's a hardware. Remember, guys, it's a hardware. You're given like it's like a key, all right? It's like a key. So and it has your keys stored there. So HSM is mainly used where there are strict compliance requirements, and for both of them, you benefit from ease of use and provided by KMS. And this approach gives you control over your HSM, and you enjoy the control given by HSM and by KMS. So, guys, the long short of it, HSM, these are hardware device that you use to generate keys, store keys, manage your keys, right? KMS, this is an AWS service that you use to generate your keys, manage them, and use them. And KMS is integrated with other AWS services. It can encrypt your data in your different storage services that you're going to use. Have you guys understood that? Have you guys understood?
Yes, we are.
All right, Gideon has understood. All right, even Sandra, thank you. Mhm. All right, all right. So let's go to data integrity. Data integrity, we said integrity is ensuring that your data is not tampered with, it's not deleted, it's not accessed, it's the way it is. If you send your data as this entire paragraph, you're going to find it as it is. All right, that's data integrity. It is as accurate, complete, and consistent, just as you stored it, as you processed it, or even transmitted it. So when it comes to data integrity, it wants to ensure that your data is received just as it was sent, or it is the same way it was when it was stored. And the major points for you to remember is that data should not be altered, it should not be tampered with, and it should not be corrupted. That's what we call data integrity. And it is crucial to ensure that there's data integrity to maintain trust. All right. One of the things that we do in data integrity, we come to Gideon's question, is hashing. All right. Let's run a let us not run. Let us learn about hashing. Now, guys, please give me around 5 minutes. I get myself a cup of water. We continue with hashing. We are almost done. Na both nicheke tu, utakula mandizi hata wewe lunch, utashema na tutakucheka. Thank you guys. Let's meet at 5. Thank you, Patrick. I am my people back. All right. Yeah, Basil is with me, Kevin is with me, Elfas is with me, Gideon. You've been here. Haukutoka kuchukua maji moto. Fanny, you're back. Gail, you're back. Roy, you're back. Abby is back. Nicodemus is back. Welcome, guys. Welcome back, Amy and Frank. Right, I think I have a few. Yes, and Daniel, tumekusikia. Wewe umekuja ukaji-announce. Wewe, we are sure. All right, so let's proceed with hashing. So who can tell me what is hashing? Haujamwaga mtama, Justin, karibu. In your who knows what hashing is? Anyone? Anyone who can give me a wild guess? Gideon, you're asking about the difference between encryption and hashing. I'm pretty sure you know what hashing is. Password hashing, all right. A process that converts any piece of data like password, file, or message into a fixed length of string of characters using a mathematical function called hash function. Yes. Hashing is like giving your software a unique key identifiable on the internet. All right. Brian Karibu. Brian Kipkiroi Karibu. All right. So hashing, thank you. Thank you so much, Rich. Thank you so much, Daniel. Thank you so much, Gideon. I appreciate your sentiments. So hashing, for those of us who are not quite aware of it, it's a cryptographic technique that is used to verify that your data has not been changed. all right? And it uses something called a hash function. So each and every software has their unique identifiable hash keys. Okay, Reg, thank you for that. Right? So we want to verify that our data has not been changed, okay? Remember that we want to ensure that our data has integrity. So one of the ways you can do this is ensuring giving a hash function to convert input data like a message, your password, your file, a specific length of string called a hash value or a message digest. So it ensures, how does it work? It takes your input, for example, say if it's your password or your file, and produces a specific value called a hash value, unique hash value. If the file changes, even by a single character or even by a bit, the hash value will change dramatically. By comparing two hash values, one can verify whether data remained unchanged. And guys, who can remind me? Yesterday we touched on it. Who can remind me the Linux code that we used to ensure that our file remained unused, untouched, unchanged? I reminded you guys yesterday. I'll be waiting on your answer. Yes, Sandra, checksum. Exactly. Exactly. Thank you, Sandra. Yes. So with hashing, it will equate our password with a unique value. And if our password changes, if our file changes, our unique hash value is going to change, right? And if it changes, you're going to get to know that someone touched something they were not supposed to touch. So the typical process of verifying file integrity: number one, a website will provide you with a downloadable file called a hash value. For example, I know you guys have seen this, SHA-256 or MD5. You can tell me where you've seen this. I know you've seen it somewhere. And EC SHA hospitali, EC ya NHIF. Hapana, in ya hashing, si ya NHIF. Na hii MD5 si ile ambao, right? So a website will provide you with a downloadable file called and its official hash value. All right. A user will download the file. After downloading the file, the user runs the local hashing tool to generate a hash value from the downloaded file. The user then compares the locally generated hash value with the one provided on the website. If both hash values are the same, then your file did not change. It was not charged. But if your hash value changes, if your hash value they differ, there's a difference between the two, then your file was altered. Okay? And it should not be trusted. So an example of Gideon, have you understood the difference? For encrypting,
Yes, yes.
all right. Thank you, Gideon. So examples of algorithms that we can use for hashing is the MD5, Message Digest 5. We have the SHA-1 and the SHA-2. SHA-2 includes the SHA-256 and 512. All right, Gideon, would you be kind enough to read for us the difference between hashing and encryption so that we answer you in a complete manner? Oh, okay. Sandra, would you be enough? We have missed your voice, Sandra. Today you have not talked to us. Sandra, would you be kind enough to read for us? Musembi, you're saying SHA-256 is used. Hey, Daniel amesema, Sandra, today is your day. Kindly bless Daniel's day. Kindly, Sandra. We beg you from the bottom of our hearts. Please.
Okay. Difference between hashing and encryption. Purpose. verifying data integrity, that's for hashing. Encryption protects data confidentiality. Process type, one-way function cannot be reversed. For encryption, two-way function can be encrypted and decrypted. Output for hashing, fixed length hash value. For encryption, encrypted text. Ciphertext. User case for file verification, password storage. Encryption, secure communication, data protection. Key required for hashing and for encryption, yes.
Thank you, Sandra. I know today Daniel has had a great day. Thank you, Sandra. I really appreciate. All right. Thank you so much. Who will be kind enough to read for me the summary? Tony, mnacheka na mnajua mimi I cannot come in between fate. Chekeni tu. Somebody kindly read for me summary. Najua tumesema hapa kuna watu walikuwa wanatumia invisible ink kuongea. Sasa Daniel amesema yeye ni kuomba tu asomewe, siku itengenezwe. Somebody kindly unmute and read for me.
Summary. Data integrity ensures that information remains unchanged and trustworthy. Hashing is a primary method to achieve data integrity. Hash values allow verification that data has not been modified in transit or storage. Algorithms such as MD5 and SAH1 are commonly used to generate these hashes.
Thank you, Basil. You get an extra 5 marks. Thank you for being so kind. Na kuna watu hapa hawajawahi kusomea. Nicodemus, Habakkuk, Alex. Sawa tu, tunawaona. Thank you so much, Basil, for reading for us. Finally, let's go to permissions. Let's go to permissions. So what are permissions? So permissions are, they define the type of access a set or a person or a user has to a certain resource, say either a file, a server, a database. So the amount of the level of access that you're given is your permission, okay? And permissions, they determine for us who can do what within the system, all right? Remember when we were talking about authorization and authentication, you said authorization, who can do what? Ukiingia kwa nyumba, can you be allowed to go to the bedroom? Yes. So if you can be allowed, you have the permission to go to the bedroom. If wewe ni mgeni wa siku moja, hata kitchen labda hutafika, you might not even get through past the door, you know? So let's learn about the key concepts of permissions. Number one, they grant a specific type of access to a resource, that's a user, to do something. For example, you can create, you can edit, you can read, you can write, you can execute. The subject, this is the user, so you've been given permission to do something. And then the object, that's something that you can access. It's the object, all right? And I've given you a good example of the house. Tuachane na user A na user B. All right, types of permissions that we have. Number one, we have the discretionary access control, and access is granted based on the identity or the user-defined rules. The owner of the resource decides who can access what. For example, like we created when we were downloading the PEM files and we needed to give them permissions. Remember that the only permission that we gave was read, okay? So this ensures no one can write, no one can do anything to it. You can only read. Okay. So with the discretionary access control, we are saying for this particular file, the only permission that users can have is to read. For example, let's say for your AWS console, and his IP, and Patrick and Salem were able to SSH to his server. Well, Justin gave permission to Patrick and Salem to access, to read, to write, to create, to delete stuff on his console. We understand now that Justin is very kind. He's very kind with permissions. The second type of permission that we have is role-based access control. And I had someone saying RBAC in the morning. So welcome to RBAC. So with the role-based access control, a user is granted access dependent on the role within the organization. For example, in our case, for example, let's just give a simple example right here. For these meetings, our admin, who is Esther, is the only one who can create the meetings and end the meetings. Those are her roles, and she can add someone, she can remove someone from the meeting. And if she removes you, okay, akutoe, hauwezi rudi kwa meeting. So she has the full access. And what about us, the rest of us? Us, we can just come and go. We cannot share unless we're given permissions. We cannot have our videos on unless we have permissions. We cannot create groups. We cannot create breakout rooms unless we have permissions. So for example, in our case, Esther created the meeting. Esther can remove anyone, can add anyone, can create breakout rooms, can send you to whatever breakout room she feels like. And then when we go to our teacher, Patrick, our trainer, Patrick, he's given the role of a trainer. So he can join the meeting, he can create breakout rooms, he can ask you to unmute, he can ask you to mute yourself, he can ask you to turn your video on, aone kama uko kwa mazingira na mazingara ya kusoma ama uko kwenye nduthi. In fact, you guys, I don't know if you guys have seen this funny video on Instagram where someone works from home and there's an online meeting and has 4 people, but one of the attendees of the meetings ako kwa bike yake, ako road trip na bike. Well, ako na permission ya kuingia kwa meeting. So if your trainer tells you, Basil, kindly washa video tukuone, you can washa your video permission. All right. If it's like right now when you're training, you learners, right now you do not have permission, say for example, of creating a meeting right here in between, or creating breakout rooms, or even recording, you see, or even unmuting someone. Let me give you a funny story of what happened when it comes to permissions, why they are very, very important. When we were learning, yeah, we were using a different video call, not Zoom. And we were so many of us, around 150 of us per class. And when someone is presenting, so this week we are learners. You guys remember when Patrick told you that you guys will teach us for a whole week? So on that week of teaching, or when someone is maybe anatoa maoni ama anauliza maswali, if it's lunchtime, people are hungry, and someone is asking 15 questions at a go, people on that video call could mute the person talking. So someone is in question 3 na kona 15 more anamutiwa. So the permissions there were very lenient, and unapata mtu anaongea, mtu anapresent, anamutiwa, right? So yes, there were no role-based access control on the video call. But yes, I hope you guys have understood. So why are permissions important? First and foremost, no Musembi, kindly do not try that. First and foremost, at least you know you will not be muted when you're talking, all right? So why are permissions important? Number one, you protect sensitive data. You ensure that accountability, you can get to know who actually went to this place, who accessed this service, who changed this file, who edited, who deleted this file, all right? So there's that sense of accountability. And then the third one, we have support compliance. So within an organization, for example, if you create your AWS account today for your new startup, and one of your compliance regulations is that you should ensure that the security of the data in the database and in S3. But then you give everyone access to the database in S3. Watu watamwaga mtama ya data yako. And you might find yourself with several lawsuits. Guys, for example, talking of compliance, do you remember just the other day, there's this big lawsuit going on between one famous radio presenter and his sister versus a pastor, right? So if there were permissions, if the lady was given permissions, yes, if the lady was given permissions to not mwaga mtama ya nyumba, asingemwaga, lakini sasa venye amemwaga, ndio watu wanakuja understand why even in a house compliance is very necessary, right? And the final thing is that it reduces risk by applying principle of least privilege. And I saw you guys got this on your KC yesterday. Was it yesterday or the other day? Where you give the minimum access needed to someone for the resources they need. No more, no less. All right. So we have a small summary of what we have learned right there. Let me just keep it and we can do something small on discretionary access control. Though tumepitia hii. It's actually a repetition. All right. Let me just go through it haraka, though we have already gone through it. So when it comes to discretionary access control, we said that this is the method of control where an owner determines the level of access you can have, like the who can control what, who can access what. And the key properties is decentralized access. The resource has the authority to grant, the resource owner has the authority to grant or revoke permissions. For example, Esther can grant me access to share, Esther can grant me access to record, Esther can grant me access to hata kuwasha video. All right, and she can revoke the rights. For example, like I do not have the rights to record, so it's decentralized, okay? And then we have access control list that says you can access this, all right? And access control entries, these are multiple access control entries. So user A can read, user B can read and write, user admin can have full control. So the access control entries, they define the specific permission that you get for a particular user or a group. For example, our admin can say all learners have the access to their microphones, but they do not have access to unmuting or muting someone, thankfully. And also there is auditing. We said that it is also you can also be able to record the number of attempts someone has tried to read something, someone has tried to change something, someone has tried to delete something. You can get that. And there's dynamic access control where access can be adjusted automatically by changing attributes. For example, on our scenario here, we can say our trainer Patrick can have access to recording and sharing. And later we can say, no, let him not be able to share. Just give the admin only the permission to share. So it's dynamic. Dynamic access control in AWS, we have IAM. So in AWS, IAM uses a similar concept where you have an access control list, and you guys, in the Knuckles, when you were setting up Knuckles, remember that you had an access control list, and you can even see the only IPs that can access your network, and you can even blacklist some IPs from accessing your network. Okay, so with IAM, you can create your own access list and you define what this user can access, all right, and what this user cannot access. And a summary table here of what we have done. Let's go quickly to RBAC. We finish the lesson. So with RBAC, we said it's role-based, and a user is given a role, and with the roles, they are created based on a specific function. They have the permissions to do something. So a certain role can be given permission to do something. For example, in our case, we can say the role of trainers have the permission to share the screen and mute, have their videos on, and share their screen and record. And you can say maybe for the role of learners, you only have access to join and leave the meeting and unmute yourself. And you can say for the admin, he or she can unmute people, mute people, ask you to have your video on, ask you to mute yourself. The admin can start the meeting. Remember that you guys cannot join the meeting before the admin, right? And even to end the meeting for everyone, like venye juzi team 153 ilichukua thamos yetu ya uji na wakatoroka nayo. Yes, so these are now ways that we are talking about RBAC. We said the key properties. Number one, it does not require constant manual updates when a staff change occur. For example, the way we've said that trainers can have their videos on. So anytime I come with a role of a trainer, I do not have to ask to have my video on. Or if I come in as an admin, I do not have to ask for permission to start or end the meeting. All right, I can just do it. And anyone else who becomes an admin or a host can start or end the meeting. So when users change, the roles remain. New users can simply just inherit permissions because they're going to partake new roles. It's scalable and customizable. You can have several users having one role. For example, you can have two trainers under the role of two people under the role of trainers. We can have the 46 of you under the role of learners. We can have one of us as a host, all right? And then there's granular control. The roles provide with a fine-tuned access, the one that you need. So we know that the role of learners cannot share their screen unless given permission, all right? So there's that granulated control, and it is commonly used. So let's see how we can do this on the cloud in AWS. So in AWS, next week, I don't know if it's on Friday or next week, I don't know if it's tomorrow or next week, we're going to learn about IAM. And in IAM, you can create users, you can create roles, and you can create something else, groups. Okay, so in IAM roles, it works the same way as a role-based access control, where you can create a role of an admin, a role of a finance team, a role of a developer, a role of such things. So if you have a role of finance, you just grant them access to finance services like cost and usage report, explorer, cost explorer, just what the finance is going to need. And after the finance cannot access anything else that is not permitted under his role. If we go to the developer, you can give the developer access to creating EC2 instances. You can give the developer access to deploying applications, but you cannot give them access to the financial services you get. So different roles have their different access controls given below. And my people, that is the end of data integrity. Have you understood? Ama mtaniambia too long did read. You guys have understood. All right, thank you so much. And we have a request for the next at least 30 minutes to 1 hour. Kindly create your meetings on Google Meets. You can use Google Meets. Go and do the labs. Like right now, you also have a lab and we also have a KC. All right. So kindly go to your groups. And yes, go do the 3 labs for the day and the KCs. Is that okay? If you're good with that, can you let me know? We need to go to our groups. Everyone has a group right now. Kindly go to your groups, do the 3 KCs, do the 3 labs,